Hello. So again, this is the third video. Only is going to be about case three of the volume of rotation and the disk method. So case three is described as such. We have the region R that is given as the set of data x equals f of y greater than 0, y equals c, y equals d, where c is less than d, and the y-axis. And this region, this described region, is going to rotate about the y-axis. The equation of the y-axis is x equals 0. So x equals f of y is this curve. Y equals c is this horizontal line. Y equals d is this horizontal line, and the y-axis. Okay. And then it says the rotation is with respect to the y-axis, which is x equals 0. So we put the curved arrows around the y-axis, and that gives us the axis of rotation. So we know the axis of rotation and the line of the cross-section line, they are always perpendicular. Because of that, the cross-section line will be horizontal, so that it's perpendicular to the line of rotation. So as we draw our cross-section line, then this time we're going from right to left. To find the distance of this line segment, right line segment, we'll have to take this point minus that point, the point to the right minus the point to the left. So at the right point, that's exactly where the function is. So at this point, we know it's x equals f of y. At this point, that's on the y-axis. By the equation, the y-axis is x equals 0. So this is x equals 0. So to find the radius of this disk, we will take f of y minus 0, which just gives us f of y. So as you know, because this line, red line, is actually touching the y-axis at y, so it tells us that everything for this problem must be in terms of the y variable, including the integral. This y tells us that whatever we do, whether the given function was given as a function of x, you must change it as a function of y before using it. Okay, so now that we get the radius, we so again, step one was to graph the region and to find the radius. So step two, we write down the radius, which is r of y equals f of y. And then, as you know, we go to the finding the disk, the area of the disk, which is pi times radius squared. So we get pi times f of y squared. And then we find the volume by taking the integral from c to d of a of y dy. So integral from c to d of pi times f of y squared dy. So that gives us the volume of rotation. Let's take an example. Again, the question is always to find the volume of rotation. So they give us this curve, y equals x cubed, y equals 8, and x equals 0 to describe the given region. And the rotation is with respect to the y-axis. So step one, as usual, we graph the region. When you graph y equals x cubed is this curve. Y equals 8 is this horizontal line. And then x equals 0, we know it's the y-axis. So that describes this region R. Now then, because the line of rotation, the line of rotation is the y-axis, we know that the cross-section line should be horizontal, so that it's perpendicular to the line of rotation. So we draw our cross-section line, and since it's touching the y-axis at y, that means everything must be expressed in terms of y, including the given function. Like this function was a function of x. We have to change it as a function of y. We cannot use it as it is. It's given. So to change this as a function of y, you're going to take the cube root of the equation, both sides. So you take the cube root of x cubed, it gives you x. You take the cube root of y, you get cube root of y. So that is the equation we're going to use for this problem, not this one. Now, when you look at the region is bounded below, in terms of the y variable, is bounded below by y equals 0 and then y equals 8. So those will be our limit of integration. So we're going to call that c equals 0 and d equals 8. So then we go to finding the radius. So we're going to start from this right end point minus the left end point of the cross-sectional line. But this point is on a curve. So we're going to call it x equals cube root of y. And this point is on the y-axis, so we're going to call it x equals 0. So when you take cube root of y minus 0, you get r of y, which is your radius. So now that we get the radius, we move to step 2. You write down the radius, and then you find the disk area by squaring the radius and then times pi. I just want to mention this. Cube root of y is actually y raised to 1/3. So when you square the cube root of y, you write 1 raised to 1/3 squared. But by the property of exponents from pre-calculus, when you square, you have two powers like this, you're going to multiply them. You're going to take 2 times 1/3, which is 2/3 as the power of y. So we can say a of y equals 2 pi times y raised to 2/3. And then we're going to find the volume, we're going to integrate from c to d a of y dy. So v equals the integral from 0 to 8 of pi times y raised to 2/3 dy. So when you integrate pi raised to 2/3, you're going to get y raised to 2/3 plus 1 divided by 2/3 plus 1. And then you're going to evaluate as 0 and 8. So when you plug in 8 for y, you get 8 raised to 5/3 minus, when you plug in 0 for y, you get 0 raised to 5/3. And by dividing by 5 over 3, by dividing something by a fraction, you can flip and multiply. So when you flip 5/3, it becomes 3/5. So 3 times pi divided by 5. Now 8 raised to 5/3 is actually 32. And then the minus 0, which is still 32. So 32 times 3 pi over 5 is basically 96 pi over 5. So that's the value that we get there. Okay, thank you.